So this first one's a little tricky. You have an equation and it's being raised to, you have that binomial being raised to the 2/3 power. So what we learned to do was we said, well, we'll raise it to the reciprocal, which is 3/2. And that's correct. Okay, on the left-hand side then, 2/3 times 3/2, that multiplication, 2/3 times 3/2. That just equals 1. And so you have x minus 4 equals, and then what do you have over here? We talked about this the other day. Well, it's the square root of 25 cubed. Remember, the bottom number is the index for the radical, so it's a square root. Now, here's the thing with this problem, and we didn't talk about this, we did the other day, but before the test, we didn't talk about it a lot. Because that is an even root, you have to do the plus or minus. Now, I didn't take off if you didn't do that because I realized we really hadn't talked about that much. So that gives us x minus 4 equals plus or minus 5, because the square root of 25 is 5, cubed. Okay, so we're going to get two answers. We're going to have x minus 4 equals negative 5 cubed. And we're going to have x minus 4 equals positive 5 cubed. Well, when you do negative 5 cubed, you're going to get negative 125. And if you add 4 to both sides, you get x equals negative 121. On the other case, you get x minus 4 equals 125 positive, and then when you add 4, you get 129. And they actually both work if you try them. So you get two solutions, negative 121 and 129. But if you had one of the solutions, most people, if they had one, it was 129. I was okay with that. All right. But really, you should have both solutions. All right. So this next one is an inequality, but it's linear. We just want to add the 22. Negative 5x is greater than negative 12. And then we want to divide by negative 5. But when we divide by a negative number, we have to switch it the other way. You do have to put this in interval notation. It says that, and I did take off if people didn't do that. You've got to get used to the interval notation. We want numbers less than 12/5. So we're going from negative infinity to 12/5. We're not going to include the 12/5 because we don't want it to be equal to. So it's kind of messy, but negative infinity to 12/5. All right. Our last one here is a quadratic inequality, and we talked about these. So this one actually happens to factor into x minus 7 times x plus 5 is greater than 0. So what you're going to do is you're going to think about your number line and where those critical values are. There's one at 7 and there's one at negative 5. You don't want to include either one of them because you're not equal to 0. That's where they would equal 0. So we're not going to include negative 5 and 7. But then we have to use test points to figure out which sections work and which ones don't. Now we have learned how to graph these in chapter 3. So you could do it that way now, but you couldn't back when we took this test. Okay, so if you try a negative 6, you would have negative 13 times negative 1, which is that greater than 0? Yeah, because it's 13, and 13 is greater than 0. So yes, this section works. Then you would try a number between negative 5 and 7, maybe 0. And you'd have negative 7 times 5. Is that greater than 0? No, because you get negative 35, and a negative number is not greater than 0. So no, frowny face, whatever. And then you pick a number bigger than 7, like 8, and that's going to give you 1 times 13. And is that greater than 0? Yes, because it's positive, so yes. And so you get the sections that I'm terribly inconsistent. Here we've got a smiley face and a yes. Okay, but we don't want that middle section. So from negative infinity to negative 5, unioned with 7 to infinity. And that would be the answer in interval notation.